So with that rudimental explanation out of the way, let's begin again. I'll quickly delete that and start over. We right click and we say texture coordinates, and we add our visual coordinates like this. Next, we want to hold down 1 and press once to add a float. We right click and convert it to parameter, and we will call that polar center. Okay? And the polar coordinates will have a default value of 0.5. Okay? Next, we want to right click and type subtract for some basic math subtraction. And we subtract from the UV texture coordinates the value of 0.5. Okay? And what we essentially accomplished here is if I preview this node, let it load really quickly. This expression shows how the green and the red are essentially kind of like your U and V. Sorry, it's a bit shiny. Maybe if I change to this, yeah, this is a bit better, so let's stay in here. But these colors essentially represent the U and the V. And when I subtract 0.5 as a value out of them, what you can see is that we shift on both axes by 0.5. See? And we centered our U and V coordinates in the dead middle of the quadrant, of the UV quadrant. So that was the first thing that we do. I'm going to stop previewing that. Next, right click and say mask for component mask, and click on it, and here change it to be just red, then Ctrl C and Ctrl V to get another one, and here change it to be just green. So you remember how I started by saying that we have the red and the green representing different UV axes. Here, by fitting it into these two masks, we essentially isolate them in order to work on each one by one. See, like it turns black and white because that is what each channel is. Perfect. Oh, I didn't know that you can do that, actually. Yeah, cool. You can do that. Stop previewing. Then we hold down M for multiply, and we multiply the result of this by its own to get us this shape. And here, we're going to copy our masks and place them here and isolate them again. Okay. While on the top, we're gonna do some trick. So I will right click and say arc tangent. Arc tangent 2 is the one that we're after. And here I will input the green axis in the X and the red axis on the Y. And let's preview that. Cool. So we have that. If you remember my demonstration at the start, we essentially are starting to describe the space. Instead of like two axes, we're starting to describe it as a distance between the point of the center and an edge. It doesn't exist, that edge, but I hope you get what I'm saying. So that's up here. Let's move that to the side. We do another mask of R, the red channel, over here. And next we do divide. Cool. Like that. We want to divide, because we're doing trigonometry, we want to divide by pi multiplied by 2. And how I'm going to do that is I right click and I say math pi to get me my pi expression. And then I hold down once to get me a value, and I put 2. So I multiply pi by 2, and that goes into the divide. We are essentially masking the R, and we are dividing it by twice pi, okay? And the result is this. There it is. So like before that it was this, and now it's this. So we are essentially kind of like are feathering it by quite a bit, which is rather cool. Next up, from here we go to frac. There we go. And let's preview that to get a sense of what's happening. And that kind of like inverts it in a way. By the way, I'll put somewhere... Well, frac doesn't actually invert. Let me open a better explanation of what frac is. So frac is a mathematical material expression that essentially does, when we input x, the result is x minus the floor of x. By the way, this is an amazing documentation that goes over all of the different mathematical expressions, and I think I actually mentioned some of them, like here I was kind of telling you how we use arctangent. So yeah, you might want to, I'll put it in the description of the video, you might want to do some further reading to solidify your knowledge. Cool. What's next? So let's go back to the branch below and the mathematics that's going on there. So here we're going to hold down A and add, and R and G will add on this. And next we want to get the square root of this. So we say SQ, or yeah, we type square root and we input that. Let's kind of preview what's happening, by the way, if you're curious. So let's preview this. So we have this kind of like circle that we're starting to describe. Preview this, like actually a perfect circle. And when we the square root of it actually kind of turns it into a dot. So next up we want give to add two adds. That's a sentence. Yeah, so like hold down A and like get an add for this branch and for the other one. And here we want to start manipulating the panning of this. So if we are panning texture coordinates on the U and V Cartesian coordinates, it will essentially have the entire texture move right or up and down depending on which axis you want. But here, because we're building up like this vortex, this circle, as I'm simplifying it a bit, we can actually control the speed of the panning, which in this case, instead of going in some directions, it will go in and out, which is kind of like really cool. To do that, we want to right click and then say time. Cool. And we want to multiply time by a value, okay? And time essentially is a constant tick, kind of like is a value that goes up constantly while the game is running. That's like what time is. We can multiply it first by one value that we'll call polar speed, and then second by another value that we'll call polar diagonal speed. Excuse me, polar diagonal speed. And I want to say default values of 0 for that, and for this one I'll go with minus 0.25. Perfect. And in the upper multiply here, time gets multiplied by the polar speed, and that goes into the B, and here the frac goes into the A. Okay, that's pretty sweet. On the lower branch, we multiply again time, but this time with the diagonal speed. And I can double click on this in order to tidy up a bit like that. So it's actually more pleasant to look at or more readable. And this multiplication can go into the B and it can go down there. So we have a bit of space, okay? While the square root can go in here. Perfect. So I'm not going to showcase a preview of this because we'll do that in a minute actually when we start building the thing. Next up, we want to expose control for, remember, like we are manipulating the UV space, but that UV space is going to be used into a texture, into a tiling texture that we'll create later in order to give some type of a visual to our vortex. And we want to give control to ourselves, the developer, later on to be able to use this shader in a more versatile way by changing how many times the texture that we're inputting tiles. By default, it will tile one by one, but maybe we want to tile it more or less in order to accomplish a different visual, which is something that I do with the red, yellow, and the rainbow effects that I made. So let's add ourselves that, and to do that we do two separate multiplies, and we give ourselves again two floats, and our top float will call tile U and then tile V for the other axis, and default values will be 1 and 1, and we multiply the results of these with those, okay? And that's how we essentially tile things, which is pretty sweet. Perfect. And now these two different like axes we want to append. So right click and then say append. There's append many, but I don't think we want append many. We want just append vector from the math directory. There we go. let's see how that is looking. Cool. We essentially have that. And with this, we've actually now built up our polar coordinates. That was the most fit. Like, this is all of the work that goes in here. I selected the one, I press C on the keyboard for comment, and I say polar coordinates in order to have this more readable. Maybe I'll change the color to something with a lower value, so it doesn't like kick me right in the eyes. And yeah, perfect, nice one. So we've built our UV coordinates, changed them from Cartesian to polar, and what we want to do next is actually apply them onto a texture. So we do right click and then texture sample, like this. And this texture sample for texture, here we'll do object, texture object, okay? And this texture object is what we'll be changing later, but for now we kind of like hook it in there. And I want to right click and convert to parameter and call this color map. Because essentially this will be like, I'll have like my default colors and emissive color control that I put over things, but I will create in Substance Designer a base styling texture of different colored noises really. We'll go over that in a few minutes. And that will go in here. So that's why I called it like that. And for the UVs, if we were to put just texture coordinates, as like it usually goes, and like I imagine you've done it many times before in your Unreal adventures, this will be the ordinary way of like using the Cartesian coordinates. But here I'm going to delete it, and instead I will use the result of the append, and I'll stop previewing this. And this is how we essentially manipulate this texture to be like polar, a polar texture. And there are a few things that I want to change here, but I'll do it in a few minutes, because for now I want to have a play with it. I want to show you how it actually looks. So we'll ignore that over there for a moment, and we'll plug the RGB of this in here. It gives us an error because I believe there just isn't anything here. It says yes, that it is. Oh, I've done it wrong. Excuse me. So this is like the view MIP bias. We'll actually work with that in a moment. When I clicked and converted it into a parameter, it kind of like made this needless. So we're going to remove that for a second. And then the error it's giving us is that here there is nothing by default as a texture. So let's change that by, can we save? Continue. Let's change it. I think we just glitched it. So let's break that connection. And now it actually lets us change it, which is cool. And here I will change by using some of the purlin or clouds noises that come in by default in Unreal Engine, because we haven't made any texture yet, but we want to like have a play. And both you and I will have this purlin noise. So let's say purlin, and see it says T purlin mask. So we apply that in here. And by the way, be aware that it changed from whatever color it was to linear grayscale here. This is the setting. We'll leave it like that for a moment, but this part is important and later we'll want to manipulate it. So anyway, here you can actually see how in the small preview this purlin mask is actually just like ordinary clouds. And now that we've put it into this node where we feed our custom UVs, see how it actually changed to like a vortex, which is really cool. And let's input that in there. Let's save. Perfect. And look at that. It immediately starts doing it, which is sweet. So I want to do a really quick cleanup, but actually I'll do it in a moment because that way you have better context.